In this video, we're going to go over the work-energy theorem. So we've already seen that work equals force times distance, and that the potential energy is mgh. So we've gone over those in some previous videos. But what I want you to recognize is that the work is in joules and the potential energy is in joules, right? So those two values are both joules. And so work is a force spread over a distance, but it's also related to a change in the energy, right? So you can imagine if somebody was traveling and going this way, they'd have some energy. And if somebody pushed them, they would go even faster. And that change in energy between their starting energy and their final energy would be the work that the person pushed them with, right? So the idea of the work energy theorem is that a change in energy is could be caused by work done on somebody. And so in these questions, what we're going to get is we're going to have an object that's at a point. It's going to go to another point, and the difference between these 2 points is the work done to cause the change. Now, there are formulas that can relate to this, but if you can understand that idea and you set up your question correctly, you can understand that work and potential energy are both in joules. If there's a change in potential energy, that's caused by work done on something, right? So if I'm lifting something, I've done work to increase that potential energy. So in this first question, it says Lewis performed a 225 clean and jerk. In doing so, he raised the weights a distance of 2.5 meters, 2.45 meters. The mass of the weight is 225 kilograms. And it's saying, how much work did he do? Well, work is equal force times distance. I mean, I kind of have a distance, but what's the force? Right? That's not obvious to me. But what I do have enough information for is I can find the potential energy at the top if I took my mgh. Right? And so I can calculate this. Down here, there was 0 potential energy. Up here, there's going to be more potential. And Lewis was the person who caused that. So in this case, the work he does is equal to the mgh because they're both energy. It started with no potential energy. It ended with a bunch of potential energy. Lewis had to do that work to make it happen. So in this case, the mass is 225 kilograms. He lifted it against the 9.81 meters per second squared. And the height that he lifted it was 2.45 meters. So if I multiply those things, the change in energy from the 0 potential to the top is 5,407.7625 joules. Well, I need 3 sig digs, so it'll be 5.41 times 10 to the 3 joules, or 5.41 kilojoules, and that's the work he did to lift that object. This next question that we're going to look at is a bit more weird. So let's read through it and see if we can draw a picture to make sense of it. It says, during a major downtown fire, firefighters pumped 800,000 liters of water to the 20th floor of a building, 86 meters above the street. So, I hate it when it does this. So the 20th floor is a height of 86 meters. So 86 meters. and it's only 2 sig digs, and that there's 800,000 liters of water. Now down here it tells us that each liter of water is a kilogram. So if it's 800,000 liters, they pumped 800,000 kilograms of water. So it says how much work was done to pump this up. Well, I don't have, work is force times distance, but I don't have the force. I do have the distance, but I don't have the force. But what I do have is I know that work is equal to energy. And so my work is going to be equal to the mgh, because down here the water had 0 potential energy, and up at the top it has lots, right? Oh, come on, stop doing that to me. Right? And so it has a lot at the top. So if I take my mass of 800,000 kilograms and I multiplied it by my 9.81 meters per second squared, and then multiplied that by my 86 meters, the work is the energy it took to get the water up that high. And so I've got my 800,000 times 9.81 times 86, and I get 674928000 joules. Blah, that's a lot of joules. I only have 2 sig digs, so my work is going to be 6.7 times 10 to, and I take my decimal, it goes 1, 2, 3, 4, 5, 6, 7, 8 spots. So times 10 to the 8 joules of energy, and that's the worst J you've ever seen. So let's do that. Slightly better, even slightly better. Okay, so you can sort of see the connection between the work being done and the energy change. Now, here it says a 3,200 kilogram elevator is lifted from a height of 10 meters above the ground to a height of 35 meters above the ground. Determine the potential energy at the start. So I haven't actually copied all of the questions that are related to this, so if you want to take a look at that, that would make sense. If this is my ground, where there'd be 0 potential energy, the elevator here is 10 meters up, and it's got a mass of 3,200 kilograms. If it was lifted up even further, a height of 35.0 meters, is going to have even more potential energy. So the potential energy at 10 meters is going to be mass times mgh, so the mass of 3,200 kilograms times a 9.81 meters per second squared times 10.0 meters, it had 3 sig digs. So my potential energy at this spot is 3,100 or 313,920 joules. So it's supposed to have 3 sig digs, so 314 kilojoules, or 3.14 times 10 to the 5 joules. Okay, so that's at this spot. Now the next question, which isn't shown here, is what's its potential up here? Well, the potential energy is mgh, and so it's still going to be 3,200 kilograms, but now it's going to be going a much higher height, 35.0 meters. So this will be 1,098,720 joules. So that's equal to 1.10 times 10 to the 6 joules. Now, if it went from here, though, up to here, the work is going to be equal to the difference between those two numbers. So the potential energy 1 and potential energy 2, I guess then if I labeled them that way, it'd be 2 minus potential energy 1, because that's the difference in energy. So if I take my 1.10 times 10 to the 6 joules minus my 3.14 times 10 to the 5 joules, that's the work that had to be done to make it go up that distance. So I'm going to try to do this in my calculator, and it's going to give me 7.85 times 10 to the 5 joules is the work it did to lift it that difference. And so again, the work is the energy difference from the starting position to the end, is a way to think about work other than just force times distance.